a heads up as to what's coming eventually. Okay, so we're going to do basically the exact same thing that we did the last 2 weeks with square roots, but now we're going to do it with cubic roots. Okay, so first we're going to talk about the cubic parent function. Okay, so the parent function for cubic is y equals x cubed. And so remember that for x squared, you do the number times itself again. So if it's x cubed, you're going to multiply the number 3 times. So it'd be x times x times x again. So you'd basically have a repetition 3 times. Okay? For the cubic parent function, your starting point is going to be the origin, 0, 0. And you can put that dot in the middle of your chart here. Okay, let's say that we wanted to plug in 1. Now, if you have a calculator, you could easily type this in. But if I do 1 times 1 times 1, what do I still get? 1. Okay, now let's do it for 2. I'd have 2 times 2 times 2. Well, 2 times 2 is 4.
Good morning, Random. Teachers, please pardon this interruption. The following student is reporting immediately to the front for you so we may leave for our compelling live field trip. LaDeja Poole, Divine McCrary, Amanda Pearson, Yasmin Harris, Samaya Turner, Monique Mitchell, Gabriella Bristow, Charlize Cole, Destiny Phillips, and Amaya Wyatt. Teachers, also please be aware if you have a young lady who has a permission slip in her hand, she's allowed to come down as well. It will say Richardson ISD, Berkman High School compelling live permission slip. So if that student has a permission slip in her hand and she's not one of the girls that I just called, please allow her to come down immediately so that we may go as well. Thank you.
Okay, so 2 times 2 is 4. Then times by the extra 2, you get 8. So go ahead and plot those 2 on your grid. So we'd have 1, 1, and then 2, 8. So I have 0, 0, 1, 1, and then 2, 8. Okay, now we're going to plug in the numbers on the other side. So the next number we're plugging in is -1 and then -2. So let's say that we're doing -1. Well, then I'd have, I'm going to write it down here, but it'd be -1 times -1. How much is that so far? They're both negative. +1. Then I have to times by -1 one more time. That makes it back to a -1. Okay, now let's do -2. So I'd have -2 times -2. And then I'm going to have to times by -2 again. Because remember, cubed, you have 3 of them. So -2 times -2 gives me +4. But then I have to times that 4 by another -2. So it's a -8 as your result. Okay, and then plot those 2 points. So -1, -1 is here. And then -2, -8 is way down here. And so what you'll notice is that on one side it kind of looks like a squared graph, but then on the other side it curves the other way. So you kind of have like a little bit of like a squiggle shape. Okay? Alright, let's talk about your domain. Okay, how far does my graph go to the left, and how far does it go to the right? Thank you. If this arrow keeps going forever and ever and ever, then my graph goes how far to the left? What about on that side? Okay, so -infinity to infinity. And then if we want to talk about the range, remember that's the lowest point and then the highest point. Okay, those are also going to be infinity to infinity. Because your graph is extending both ways. It doesn't turn around like a parabola does. Okay, and it doesn't have a starting point like a square root function does. Okay, so then the next question is, does it have a symmetry? Remember, there are 2 kinds of symmetries. The first kind of symmetry is a reflectional symmetry. So like for a parabola, let me sketch it down here. Okay, if you were to draw that line in, that's called a reflectional symmetry. Okay, and this graph doesn't have a reflectional symmetry, but do y'all remember the other kind? Close. It's a rotational symmetry. Okay, so yes. Okay, it has a 180-degree rotational symmetry. So basically, if you were to take this little squiggly shape and flip it around, it would look exactly the same. Okay? Alright, now we're going to take all the properties that we used on square roots and on quadratics. We're going to now apply them to the cubic function. So your general form is going to be this: y equals plus or minus a x minus h cubed plus k. All of the numbers do the exact same things that they did on the other ones. That's why today should be a little bit easier. The plus or minus in the front tells you whether your graph will be reflected across the x-axis or not. Okay, remember, in the case that it's a negative number in the front, that's when it would be reflected. If it's not negative in the front, it would not be reflected. Okay, second number is your number in the A spot. Okay, that's going to tell you if you have a vertical compression or stretch. And then remember that for the compression or the stretch, the cutoff is 1. So if it's bigger than 1, that's a stretch. And if it's less than 1, that's a compression. Okay. So a compression is when it's less than 1. A stretch is when it's greater than 1. Okay? Next number, in parentheses with the x, it's your h. That's going to tell you whether you're going to shift your graph left or right. And then remember, the number at the back tells you if you're going to shift your graph up or down. Okay? But this is going to be super similar to all the other ones that we've already done. Okay. Alright, so come down please to the graphs down here at the bottom. Okay, so for your first graph, write down your starting point. That's going to be where you're going to shift the point that's normally at the origin. So, for example, if I'm doing this one right here, I see a minus 6 in parentheses. Which direction am I going to shift my graph? Good, to the right. So to the right, 6, and then what about the plus 2? Up 2. So I'm going to count to the right, 6, up 2. I'm going to put my first graph. Starting point is 6, 2. Okay, then when you draw your graph, every time, the right side curves up, and then the left side curves down. Okay, and so if you break it into halves, it'll be easier to sketch. That side goes up, that side goes down. Yes, sir? The starting point was at 6, 2 because we took the opposite of this number. So if it's a minus 6, you switch it to a plus 6, and then the plus 2 tells you to go up 2. And that's like the middle, the center of your graph. Okay? Now, think about your domain and range for a second. How far to the left does this graph go? Negative infinity. How far to the right does it go? Positive infinity. What about your up and down? How low does it go if I have an arrow? Negative and then positive infinity. So for all of these graphs, no matter where you shift it, because the branches are facing opposite directions, okay, these are always going to be negative to positive infinity.
Interruption. Last call for Yasmin Harris. Yasmin Harris, please report to the front for Yasmin Harris.
Okay, the other way that you could write that, instead of having to write the infinities, is that, remember, you could do this, or you could do this. Okay, and remember that the IR stands for all real numbers. So you wouldn't have to write both, but you should recognize both. This means that X can be all real numbers. This means that Y can be all real numbers. Okay? Alright, so let's scooch over one, look at the next one. Okay, think about where we're going to put our starting point. I have a plus 2 in parentheses. That means I'm really shifting to the left 2. Minus 8 tells me I'm shifting down 8. So I'd go left 2, down 8, put your start point. Okay, then from there, remember the right side of the graph normally arches up, the left side normally arches down. But we have a negative in the front. And remember that your negative in the front is going to flip your graph or reflect it across the x-axis. So instead of drawing this side curving up and this side curving down, you're going to do the opposite. So this side is going to curve down and this side is going to curve up. Okay? And remember, it's reflected to go down because there was negative in the front. Okay? Then your domain and range. Your domain is x within all real numbers. Range is y within all real numbers. If you want to put negative infinity to infinity, though, that's totally fine. Okay, when you're ready, flip over to the back. Okay, and let's do the back side. So, next one, what will my starting point be? Yep, negative 7 plus 1, good. Okay, so negative 7, 1 is right there. And then normally my right side goes up, my left side goes down. But in this case, if I have that negative in the front, remember that that negative is going to make it backwards. So instead of squiggling up, it's going to squiggle down on that side, up on that side. Okay? And then your domain and range will be all real numbers again. Okay? One more like that. Look at the next one. Okay, we have a plus 5 in here, a plus 6 out here. Plus 5 is going to turn into a what? Negative 5, and the plus 6 will turn into a still plus 6. So negative 5, 6 is going to be here. And then remember, if there's not a negative in the front, the right side aims up, the left side aims down. So that side goes up, that side goes down. And then remember that this one here in the middle, this is the parent graph before you shift it. So that's just to remind you of like the general shape. Okay? Alright, there's one more that we have to look at, and I want for you to type it into your calculator. But I want you to notice that on this next one, the negative is inside the parentheses. So when you type it into your y equals in your calculator, you're going to put it like this. It'll be y equals parentheses negative x minus 3 cubed minus 4. So when you type it in, you're going to put the negative on the inside of the parentheses. Now, for square roots, does anybody remember a negative in the front would flip it down? How would a negative on the inside flip it? Do you remember? Backwards. Okay, so we're going to see if that still happens here. So I'm going to come in here. Okay, I have parentheses negative x minus 3 cubed and then minus 4. You type it in just like that. Okay? And then once you type it in, hit graph, and we're going to see if the graph looks different than when you reflect it upside down. Okay, so it shifts to the right 3, down 4, but then look at your shape. It's down on this side, up on that side. So 4 cubics, it doesn't matter if the negative is inside or outside. It's going to flip it the same way. This is why. Okay, come up here and look at this first graph. Okay, think about, can you kind of see that these are like flipped from each other backwards? So since it's a 180-degree rotational symmetry, it doesn't matter which way you flip it. If you flip it upside down, it's going to look like this. If you flip it backwards, it's still going to look like that. So the good news about cubic roots is you don't have to worry about multiple directions it could be flipped. It's always just going to go right side down, left side up. Okay? So I'm going to put here negative inside is the same as a negative outside. Doesn't matter, but remember that for square roots, that does matter. Okay? Alright, so my starting point will be what? Okay, 3 then negative 4. Remember that goes in the middle of my chart. And then while you have it typed in, we're going to pick specific points for this one. So I'm going to come in here to my table. I'm going to go to 3, negative 4, and I'm going to look at the points around it. So the points above it are 2, negative 3, and then 1, 4. The points on the other side of it are 4, negative 5, and then 5, negative 12 is not going to fit. 4, negative 5, and then 5, negative 12. Okay, so let's graph those dots. 1, 4 is here. And then my other dot, that one would be way off the grid. And then remember, the way you connect them is the right side is curved down, the left side is curved up. And remember, the reason it's going that direction is because of the negative in the front. If that negative wasn't there, it would be flipped the other way. Okay? Then remember, your domain and range are still x within all real numbers, y within all real numbers. And the reason why is because those arrows are pointed opposite directions from each other. Okay? Next question says, for cubics, does it matter if the negative is inside or outside? We talked about that, so I'm just going to put no. Okay, then we have 3 more left, where instead of actually having to make the graph, you're just going to have to list out what the changes are. So, for example, if I was looking at number 1, okay, I have 3 numbers that I have to address how they're going to change the graph. This one, and this one. So, for the 1/8 in the front, that's either a compression or a stretch. Which one will it be if it's an 1/8? Okay, very good. That is a vertical compression. And remember, the reason why is because that counts as less than 1. Okay, an 1/8 is smaller than 1. So that makes it a compression. Okay, then I have a +3 in the parentheses. Which way does that translate my graph, left or right? Okay, to the left 3. And then the -1 is going to shift my graph to go down 1. Good. Okay, take a look at number 2. Okay, this time I have 4 changes. Okay, so I have the negative, I have the 2, I have the 6, and I have the 17. Okay, the -2 has 2 jobs. What does the negative part do? Okay, it's going to reflect it down or flip it down. And what does the 2 do? A vertical compression or a vertical stretch? Stretch. And don't get confused about it. If you think about it as a -2, you're like, oh, that's less than 1. No, you're only looking at the 2. 2 is greater than 1, that makes it a stretch. The negative reflects it down. Okay, so that's also a vertical stretch. Okay, then your last 2 changes, I have a -6 that translates it to the right 6, and then the +17 translates it up 17. Okay? Alright, next one, take a look at number 3, please. Okay, number 3. So, if we were to work this one out, we have a negative in the front. Negative in the front does what? Okay, reflects it down. Okay, then the next number that you see is the 1/8. Now, normally a 1/8 would be a what? A compression. But, I don't know if you remember this, we talked about it last semester. If your A is inside the parentheses, it actually does the opposite. So normally this would be a compression, but since it's inside, that actually makes it a stretch. Okay, so that would be a horizontal stretch. And the reason why is because your 1/8, which is less than 1 and normally a compression, is on the inside, that changes its job to be the opposite. Okay? Then I have a +4 in here, that's going to shift it to the left 4. And then you have a +6, that's going to shift it up 6. But remember, for that all three of those, no matter how you flip it, move it around, blah, 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 your domain and range are still going to be all real numbers for all three of those, no matter where you put the graph. Okay? Alright, so take a look at your homework. Okay, it's pretty short. You should be able to finish it today. And then we'll get into inverses with these tomorrow. Okay?